we have a question. This question. The question which is in front of you. Uh, this question is based on trigonometry. Yes, this is a separate chapter of standard 10th, you know, and we are going to solve this question. You have know that this given question is based on trigonometry, and I will not tell you concept of this lecture because we have selected some questions, and in this lecture we will be uh, solving a lot of questions based on this lecture. Let's see this how to solve this. Sometimes you will realize that yes, we are using trigonometric functions. Sometimes we will be using trigonometric identities. A lot of things. According to question, what is a question say? Question saying that use this formula, then we will use that formula. Now let's solve this. We are not coming. We didn't come here to waste time. We are jumping on the question. First step is to read. Just read this question. What is it saying? You should have clarity after reading this question. If you don't have clarity after reading this question, then again read this. Read many times until you get clarity. Here it is saying in a triangle ABC. Okay, we have a triangle and name of each coordinates of the triangle are what ABC. Okay, right angle. We have right angle triangle. So first, one side would be perpendicular. As you know that perpendicular gives a right angle, a 90-degree angle. So right angle would be at B. Here you right angle would be at B. This point remember. Then here we have a measure for one side, which is a 24 centimeter. From A to B should be 24 centimeter. And next BC is given, which is 7 centimeter. We have given measures of two sides, this one and this second. What about third? Third is not given. Measure of a third side is not given, and that is what we will find the third measure of a third side by using something. Now, to till here we have read. It is saying that you can draw a triangle and then you can name this ABC. But remember, B at B should be right angle, and here AB is what 20. So let's draw it like that. Here, this perpendicular, this perpendicular is making how much? As you know, 90 degree. 90 degree. Okay. So this is at B. We can say this A and this is A. So this is a figure diagram of this equation. Now, what is the measure of this and what is the measure of this side? Look at here this equation. AB is 24 centimeter. So this AB, this side is 24 centimeter. And what about the BC? BC is 7 centimeter. You are observing that this is not a perfect diagram of this equation. Yeah, I also know. Just for understanding, I draw some word like that. We don't have given this. We have given only this. Can we find this? Yes, it is possible to find this hypotenuse. Yeah, you can see this perpendicular. This perpendicular is what? It is the opposite of this. Here, this is known as hypotenuse. Hypotenuse. You are already familiar. This is a hypotenuse. As you know that a hypotenuse is fixed. So here, after finding AC, we will have to solve this is sin A, cos A, sin C, cos C, according to theta. So let's find this AC by using Pythagoras theorem. So here, as you know that AC would be what? AC square, then AB square plus BC square. AC is not given, it will be as it. AB is 24, then BC is 7. Clear? Totally, till here we just substituted value of this side and this side. Here 24 raised to power 2, how much? 24. 4 4 is 16, 1, 4 2 is 9, 2 4 is 2 2 is 4, 6, 7, 5, 576. It is given 576. 7 7 is 49, enough. So after simplifying it, you will get 625. And when it will come this side, this will be root 600. And here you can see 625 is the perfect square of 25. 5 5s are then 1, no, 2, 5 2s are 12, then 2 5s are then 1, 2 2s are 4, 1. 5 2 6, here you can see what is happening. It is the exact perfect square of 25. So it is telling you that you got a AC as a 25 here, this 25. So finally, we have brought this side measure of this side. Now, what else should we do ahead of it? Let's simplify this and this. 1. In this one question it is saying, what is the ratio of a sine? What is the ratio of a sine? You are crystal clear that here theta is a. According to theta, you will determine, what should be perpendicular, what should be base. Theta will determine. So here we angle is what? Here, this, here. According to this theta, opposite of this is this side. So this side, you will consider this side as a perpendicular and this side as a base. Okay, according to theta. We know that ratio of sine is nothing but this perpendicular BC upon AB, and this is how much? 7 upon 25. This is the ratio of a sine. You can simplify it and further you will get a number which would be in decimal. If you don't want to go ahead of this, then till here this is your answer. Next, cosine. Just opposite this, BC. So this would be AB upon base upon hypotenuse. AC. So this is how much? 24 upon 25. This is the ratio of a cosine. That is how you will solve. Next question we have. This is second. This is second question. Sin C. Now here, what's the difference between sin A and sin C? Just theta. Here theta is given A and here theta is given C. So look at here C. Look at this is C. According to this is opposite. So this would be perpendicular for now. So perpendicular is what? AB upon AC. Hypotenuse is fixed, you already know. So here AB is how much? 24 and AC is 25. To tell here, this is your answer. Ahead of this you can simplify it. Now next we have cos C. Cos C. And cos C is nothing but just opposite. So this base upon this, BC upon AC. It is giving you 7 upon 25 centimeter. That's all are your answer. This is done. We have answered a first question, and I am going to write next question. Just have a look here. Now next question. Did you understand how did I solve this question? I, this was the first question, and you can say it is a very easy. As we will move, as we will keep moving, then we will be jumping on advanced question from basic to advanced. So let me erase it. Next question we have. This is a complete question, and it's next. How to solve this question? It is a different from the first question. Question is the same. You have given a figure, just figure, and find this. We know that from a statement, anybody can interact with a statement. So we will continue here. This is a given figure. In this given figure, you can see we have given measure of this side, which is a 12 centimeter. This is a 12 centimeter, and this side measure of this side is a 13 centimeter. But you can see here we don't have a measure of a third side, which is a QR. This side. First, we have to find measure of this side. This side. So for this, we will use what? So as you know that this is a base. This is base. So here would be what? PR square 4QR square PR square minus QP. This is not given. It will be as it. PR is 13 centimeter. 13 minus 12. Okay. This would be 169, 144. Then we have 25. This came as a 25. Here, as you know that here we have a square. So when it will come this side, then it will be a root. So finally, we got this 5. It is saying that this is your 5. This is your 5. 5 and then 2. Yeah, this is right. Now let's apply this and this in this. Whatever is given to you, you can write first of all. For example, QP is a 12, then PR is a 13, then QR is a 5. Okay, QR is a 5. Now let's see. tan phi minus cot r, tan phi minus cot r. As you can see, P is over here, P is over here. So opposite of this would be perpendicular and this would be phase. So can we say QR upon QP, and then we have a chord just opposite of this. So remember, this is a P and this is R. It's a P and it's R. So according to this data, chord ratio of chord would be what? This perpendicular and this base. So first of all we need a base. So QR, and then QP. Now this is a correct way. Now we will have to substitute value of this QR, QP. So here QR is how much? QR is 5 and QP is 12. Okay, to take till here this is correct. QR is 5 again, then QP is 12. And what to do further it, you know, just 12 as a 5 minus 5. It is giving you 0. It is giving you 0. So this answer is telling you that this is equal to this. Value of this is this much. Okay. So this would be your answer. This would be your answer. Now I am going to write the next question. It is this answer which came is right. Let me write next question. Next question we have third. This question. It is very easy. Just try to understand. And first of all, read this question. And if you go to clarity, then take an action to solve it. If you are making mistake, don't worry, it happens. First of all, after reading this, just take action. If you got understanding. Now here, sine is a ratio of a sine is given, which is a 3 upon 4. Okay, this is a 3 upon. Whatever is given, you can write. Yes, sine is this is given. You know that ratio of this is in variable is what? Perpendicular upon hypotenuse. So this is given. Meaning of this is what? P is 3 and H is 4, but we don't given B. We don't given B. For B, we can use Pythagoras theorem. So here H is given. So H square and P square. B is not given. For B, P square minus H square minus P square. Okay, this would be as it. H is how much? Just put value 4. Then P is 3. Simplified 16. 3 3 is 9. It would come as B came as a 7 in under root of 7. So we got B as a under root of 7. So here Kishan is asking, Kishan is saying that calculate this cos A and tan A separately. So cos A is what? According to, yeah, it has a set. Cos A. Cos A. We know that this is just a base upon hypotenuse. Base upon hypotenuse. So base is what? Root 7 upon H is 4. Till here this is answer. As you know that whether it can be simplified. It's up to you. This is your choice. If you don't want to go further it, then till here this is your answer. Next let's take this tan A. Then here we have to find what is the ratio of tan A in mathematics. So here this is nothing but just perpendicular upon base. Perpendicular is given, which is a 3, and base is nothing but root of 7. It can be simplified further. It's your choice. So finally, we have done this question. What did we do? Just we saw that yes, we have given this P as a 3, H and H as a 4, but we don't have given B. So we used this method, this theorem, to calculate a measure of base. Then here we applied all this in the ratio of trigonometric function. Then we are able to solve this cos A and tan A. Now next question. Just have a look and I will take next question. What question? Read this question. It is saying that you are given coordinate, but it is in this way. Here you can see we have given this 15 cot A. Till here you don't need to worry. Just simplify this. When we will simplify this, then we will get a cot A as a 8 upon 15. Now you are observing something. That ratio of this cot A is this. Now we know that ratio of a cot in a variable is nothing but just base upon perpendicular. And here B is a 8 and P is a 15. We don't have measure of H, measure of hypotenuse side of the triangle. Here we will use same Pythagoras theorem. So here for H, B square plus B square. P is a 15 and then B is a 8. 15 times 15. I think it should be 125. Then 2, 5, then 7, 2, 2, 2. 225. 225. So it is 225. Then 64, 9, 8, 2. 289. Then 7, 5 5s are, then 5 to 7. What the hell? Yeah, that's right. 2, 64, then it became 9. So what is that number which would be perfect as part of this? So I think it should be 13. No, 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 no. It should be what? We have got 289. So 13 would give us 9, then 3, then again 13. 9, 6, yes, 169. 14, 14. I think 17. 17. 4, then 11, 9, 8, and 2. Yes. This 289 is the perfect square of a 17. Now, here this 17 came as a h. This h. We got h as a 17. Now, find this and this. Sin a, we know that it is nothing but just perpendicular upon hypotenuse. So perpendicular upon hypotenuse, perpendicular is how much? 15, and hypotenuse we got 17. So it would be 15 upon 17. Now next we have sec. Sec it is the same. What? First of all, h would become hypotenuse, and this is a reciprocal of a cos. Reciprocal of a cos. So 4 cos this. So finally, ratio of sec a is hypotenuse upon base. Now, h is how much? 17, and b is how much? 8. 8. So this is your answer. That is how you will solve. That is how you will solve. Look at here. Now I am going to write the next question. I hope you are writing with me. If not, then you can pause this video to write to understand this question. Let me erase it. Fill. It's the next fifth question, and this is complete question. Read this carefully. It is saying that you are given what? You are given this much ratio of a second, which is a 13 upon 12. 13 upon 12. And we have to calculate all this trigonometric ratio apart from this. So we left 5 for trigonometric ratio, which is sine, cos, tan, cot, cosec. Okay, cos. First of all, let's see, do we have measure of all sides of a triangle? No, just we have measure of two sides of a triangle. Here this is nothing but just h upon, it is just a reciprocal of a cos. So here it would be nothing but b. Okay. You are observing that value of this, measure of this h is a 13 and measure of this b is a 12. We don't have measure of perpendicular. In that case, we will use theorem, which is a Pythagorean. So for perpendicular, h square minus b square. P is not given. H is a 13 and b is a 12. Here it would be 169. 169 is the perfect square of Pythagorean, and this nothing but 144. This is a perfect square of 12. Now this square will come in this side, then it will convert itself into root. So finally, after this subtract, when we will subtract this from this, then we will get to 25. Yeah. So you know that this is a perfect square of a 5. So at the end we are getting this fact. This is a measure of a p. So p came as a 5. P came as a 5. Now what else? Now we are able to calculate all trigonometric ratios apart from this. So let's start from sine. Okay, it is nothing but just p upon h. Okay, p upon h. Then cos theta is a p upon h, and then we have tan. Tan is nothing but p upon b. P upon b. Then cot. This is a b upon p. And then cosec. Here you can see this is just a opposite of this, so it would be h upon p. H upon p. It is a reciprocal of a sine. Right now, from here to till here, you have all 6 trigonometric ratios. And that is what question was asking to calculate all this. So here p is a 5, h is a 13. This is a ratio of this trigonometric function. Now next we have cos. So b is a 12 and h is nothing but 13. P 5, b is a 12. B 12 and p is 5. Then we have h 13 and p is 5. This is our final answer. We have calculated all trigonometric ratio. We are able to calculate all this 5 ratio for this 5 trigonometric function because of this is given already. That's why. With the help of this, we got this measure of this p. With the help of this, we are able to calculate all trigonometric ratios. This is what is the process of solving question. Now, shall I erase it to write next question? Yes, I should erase. You can pause this. Have a look for few seconds. I am giving you for few seconds so that you can understand this answer. Now next question, let me write. That's your question. How would you like to solve this question? This type of question? Do you have any idea? I am telling you, this is a very easy question. Just understand this. Here, this part, cot A, cot theta is given 7 upon 8, and ratio of a cot is what? It is a ratio of a cot theta is what? Just B upon P, B upon P, B upon P. So here B is 7, P is 8. H is not given. For H, you know, 8 square plus 7 square, 64, 49. And here H is coming as a 113. H is coming as a 113. Now let's solve this first. We know that here there is a one thing is coming, which is algebraic identity. You are already familiar with that identity. A plus B and then A minus B. This is what algebraic identity. Here we can apply for saving time. A plus B, A minus B, it is nothing but A square minus B square here. So 1 plus, not plus, minus, sine square theta upon 1 minus cos square theta. Here we just applied algebraic identities so that we can save our time without any lengthy process. Look at it. Just substitute the value of this is sine and value of this is cos. Then after substituting, then simplify. 1 as it. Then this is what? P upon H. P is 8 and H is nothing but 130. This fraction is in a square. And in denominator we have cos. It is what? B upon H. So B is 7 and H is nothing but this is 130 in under. And now we have to simplify this. We have substituted value of the sine and cos. Just simplify it, then you will get answer. Here you can see this fraction is in a square. So 8 will be 64. And this square will cut this. And the same here. 7 sons of 49. Then this will be as it. It is very simple. Now, what is happening over here? We will simplify it, then it will give us 113. Then here would be 113. Then hold on, not yes 100. Then here this as it. Then upon 130. Then here would be 130 minus 49. This will cut. We left this. I think 9, then 4. And here it is how much? 4 and then 6. You know that this is the 7 sevens and this is the 8 eights. So finally answer then 7 upon 8. Answer came 7 upon 8. It is, this answer is telling you that this is equal to this. Value of this is this much. Now next we have quarters quadrant. Next we have quarters quadrant. Just here you know that ratio of this is nothing but just b upon t, and b is 7 and h is this much, and this is the answer for this question, and this is answer for this question, not for this question. That is how you will solve. Here you can see we just found measure of this is, then from this measure of sides we were able to solve this, calculate this. Then here we used algebraic identities, then we simplified it. Then after simplifying this, we got this much answer. Then this is done. After it's done, we came here on this question. Then here, this was very easy. Just we put value of b and value of p. Then it came as a result, as output. Did you understand? Now let me move to the next question. Here remember, one thing I did a mistake is that this is in a square. This is in a square. So it would be 49 and this would be 130. So here P is how much? P is 8. P is 8. So it would be 64. This is the final answer, and you know 7 sevens are and 8 eights are. 7 upon 8. Let me write next question. Next question would be different from the previous question. It's a complication. Just read this carefully. I am giving you some minutes, few minutes, so that you can have clarity after reading this question. I'm telling you that it's very easy. Just you need to read this carefully. Did you read? Did you read this question? Now let me explain this. Here we have given this cot A ratio is how much? Ratio of cot A is 4 upon 3. This is nothing but P upon P. B is 4 and P is 3. We don't have value of H, measure of H. For H, just 3 square plus 4 square. 3 3 is 9, 4 4 is 16, then 25. 25 is the perfect square of 5. This is a perfect square of 5. Okay. So from this we got measure of H, which is 5. So we have measure of B, measure of P, measure of H. Now we are able to prove this. This is saying that is this left hand side is this equal to this side. This is what we have to tell just by solving this. When value of this would come equal to this side, then we will say yes, this is equal to this. But with proof, and proof will come when we will solve it. There should be logic behind your process, behind your solving question. So let's start with this. First of all, we will simplify this, then this. Here we have LHS. LHS 1 minus tan square A, then this is upon 1 plus tan square A. Okay, clear? Okay, just substitute value. Just a substitute value of tan here. 1 as it. Now tan. We know this is nothing but just P upon B. P upon B. P is, what is a P? 3. And P is 4. And you know that this fraction is in a square. This fraction is in a square. So 1 in denominator. What about the denominator? Here same. Okay, 3 upon 4. Now our work here, ahead of this, our work is to simplify. That's it. We are not going to substitute after this because we have substituted. So let's simplify this together. 1 upon 1, then here 3 3 is 9, 4 4 is 16. Next we have this denominator, same here, 3 3 is 9, 16. 16 and then 16 minus 9. Then again 16 minus 9. This 16 will cut to each other. Then this is here. 16 minus 9. It would be how much? I think so 7 upon 7. It is coming 1. This is coming 1. Is it correct? 3 3 is 9, 4 4 is 16. 1 minus. So P upon B. Yeah, this is correct. So it is coming 1. Let me check, is it correct or not? Here one thing I did wrong, I did make mistake is that here this is a plus, okay, this is a plus. So it would be 7 upon 25. Now this is correct. It is a LHS. No, RHS. RHS is a cos square A minus a sin square A. Cos square A minus a sin square A. Cos A is what? B upon H. B upon H. And sin A, B upon H. Just substitute value of this. So B is coming as a 4 and H is a 5. This fraction is in a square. P is how much? 3 and H is 5. It is in a square. Now let me say add of 4 for the 16, it would be 16, 25, 3 3 is a 9, 25. Here 25 has it, 16 minus 9, it is coming 7 upon 25. Here you can see what is happening. This is a RHS. Look at here. LHS is equal to RHS because of both are same. So we can say at the end we would say yes, LHS is equal to RHS. And with a proof, with evidence, we said. Look at here. We started from here and we ended till here. In this, we used this theorem so that we can get measure of H. After getting this H, we started calculating this LHS. Then here, we substituted value of tan and same here intermediate. Then after simplifying this, we got this much answer. After LHS is complete, then we moved it towards the RHS. Then here we saw what ratio of cos and ratio of sin. Then after substituting value of this fraction, then we simplified, and after simplifying you can see we got this much. And here you can see this is equal to this is coming is equal to this. That's why both are equal here. Now let's move towards it. Now next question. Next question is 8th. 9. In triangle, right angle at B, if tan A is equal to 1 upon root 3, find the value of This is very different from the previous, I would say. But there is a connection of the previous questions with this. Look at this question. In a triangle ABC, we have a triangle ABC. Right angle is at B, and ratio of tan is given, which is a 1 upon root 3. First of all, let's draw a triangle figure. Okay, look at here. This is a triangle figure, and it perpendicular is at the B. Here, this is nothing but A and C. A and C. Now, tan is already given. Tan is already given. Tan. According to this theta, this is a perpendicular. Okay, so it is given. Tan A is nothing but 1 upon root 3. 1 upon root 3. This is given. Now we know that the ratio of a tan A, it is 1. Just P upon P. Here B is given, which is 1, and B is given, which is a root 3. But what about H? So here, according to this data, this is a perpendicular, which is a 1, and B is a this. This is a root 3. But what about this hypotenuse? For this, we will use theorem here. For H. Just add this and this. 1 square, then root 3 square. What is happening over here? It is giving you 1 plus 3. 1 plus 3, which is nothing but 4. And H is coming as a 2. This is coming as a 2. So finally you got H as a 2. Okay. Now, ahead of this, what should we do? Ahead of this, we will calculate this first. Sin A, cos C, then cos A, sin C. Okay, let's calculate this. Here, ratio for sin A is I think P upon H, and then remember, here you will have to pay attention on theta. Here, this is sin. So according to this, multiple and cos C. So P upon H, then cos P upon H, then P upon H. Now here, look at here. P is how much? But according to this A theta. So this is here, this is a P. P is a 1. P is a 1. And H is a fixed, which is a 2. Okay. According to this C theta, B is this one again, B1. B is a 1 and H is the same. Now next, according to A, this is a P, so B would be this, root 3, and H is a fixed 2. Then here, according to C, this is a perpendicular, and we need perpendicular, root 3, and hypotenuse is a fixed. Now let's simplify this. Here, this will become 4, and this 1. Here it is addition, 2 to the 4, 3 3 is a 9, and 9, as you know that 9 is a perfect square of the 3. Okay. Now simplify it. It will become 4. Then here 1 plus 3. What is happening over here? We are getting 1, and this is the answer for this question. We got 1 as a output. Here try to see here. This is our input, and this came as our output. Now next we have this. It is nothing but just cos A cos C minus sin A sin C. Is it difficult to calculate this? No. Just here you will get confused about the theta. Here theta is A, here C, here A, here C. Your focus should be on here. 75% of your focus should be on this theta. Then your answer will come correctly. Now let's simplify this. Cosine, it is nothing but just P upon H. Then again P upon H. Then P upon H. Then multiple P upon H. I know this both are same, but it will become different to each other according to this theta. Now let's substitute value of these fractions. According to this A, perpendicular is this and this will be this. So root 3 and H is a fixed. Again, not same root 3. No, root 3 will not come again. Here according to this C, this is a perpendicular and it would become base. So this is over here is 1, H is a 2. Now here according to A, P is this 1 and according to C, this is a P and H is a 2. Now our work is to simplify this further. 2 times 2, 4 and root 3 ones are root 3. 2 2s are 4, root 3 ones are root 3. So now here 4 has it, root 3 minus root 3. This will become 0 and upon 4. This is in numerator. If this is in the denominator, then it will become infinity, not at all. Here, this 0 is coming in numerator, that's why it will become 0, not infinity. So this came as a 0. Our output came as a 0. This is answer. This is answer for this question. That is how you will solve. That is how this type of a question is solved. Just have a look for a few seconds.